So in this lesson 1-2, linear measure, we're going to take a look at some segments and some measuring of segments and some calculations with those measurements. So first, we've got some definition. A segment or line segment, it is part of the line consisting of 2 points and all the points in between them. So we have a name of a segment AB or BA. Can go the other direction. So that would look like this right here. That's a line segment where it's stopping there. End point would be considered that point there at the end or over here on this end. So A or B, and it could be the end of a ray or it could be the end of a line segment. So end point, and then this is the line segment itself. So we're going to look at some measurements here using our ruler. So this one, we are at the length of AB. So it looks like we're using millimeters. So 40, and then we count 1, 2, looks like, and it's kind of hard to tell here, it looks like 40, and then there's 2 tick marks that were past the 40. So we would be at 42 millimeters. Now in this next one, we're in centimeters, and it looks like we're halfway between 4 and 5, so we're at 4.5 centimeters, or 4.5 centimeters. On this next one, DE, we're right there at 3, and we're in inches, so 3 inches. This next one, we're not quite to 3, and we look at how many lines are between 2 and 3, and we have 1, 2, 3, and then 4. 4 of them means that we're going up by fourths. So 1/4, 1/2, 3/4. So we're at 2 and 3/4. And that's inches. So you definitely want to put those labeling on there. So now we're going to have kind of a description where point M is between, so at some point between these we're going to have a point M between P and Q, and so then we can add up this segment plus this segment, and then we'll get the whole. Okay, so this postulate, a statement that describes a fundamental relationship between basic terms in geometry. We are going to talk about this segment addition postulate. So basically, if we add up, like we talked about, ML plus LW, then that's going to equal the whole thing MW. So that's the segment addition postulate. This segment plus this segment is going to equal that total, that whole. So let's practice it with some numbers here. So this segment plus this segment, we're going to get XZ, which is what we are looking for. Find XZ. Assume that the figure is not drawn to scale, so we're just going to add this segment and this segment to get our XZ together. So 4 5/8 plus 2 1/2. So dealing with some fractions here, so we do need to take a look at what 5/8 and 1/2 could be added together. So we know 4 and 2 is going to get our 6. So that's going to be 6, but then we need to change this into eighths. So 1/2 we know we can make into 4/8. So now we can add our 5/8 plus our 4/8, which is the half. So 6 plus 5/8 plus 4/8, and that's going to give us 9/8, which we can change into a whole, because if there's 9 and 8 is what it takes to get a whole, we have another whole we can add. So it's 7 with 1/8 left over. Okay, so got to work with our fractions here. Decimals, it's a little bit easier, but this time they're giving us the whole length and they're giving us a part, so we need to figure out what this part is. So we know LM plus 2.6 is equal to that whole of 4. So now we can go ahead and take out and subtract that 2.6 from the 4. And that's going to leave us with what LM is, which is 1.4 centimeters. So it helps to draw a picture, especially when they just give us words and stuff here. So let's go ahead and just draw a line. And then it says that we know that X is what we're looking for, and MN is what we're looking for. Then it's going to give us the description. N is between. So let's just go ahead and throw N in between here somewhere. And then between M, so M's at the end, and P. And it's not necessarily in the middle, but for now we can just go ahead and put N between M and P. So MP is the total, and it looks like that's 60. Then we know MN, so we're going to put that on our picture here, is 6x minus 7. And we know NP is 2x plus 3. So this left side plus this right side is going to equal our 60. So we're going to set that up. And here it is in kind of word form. MN plus NP equals MP. MN plus NP equals the total. So 6x minus 7 plus 2x plus 3 is equal to 60. Now we can combine our like terms here, and negative 7 and 3, and then add 4. 8x is equal to 64, which means x equals 8. That was one part they wanted, find the value of x. Now they want mn. Well, mn is 6x minus 7. So we want to take 6 times 8 and then subtract 7. So that's going to give us 41. So let's talk next about what congruent means. The difference between congruent and equals. So congruent means the segments have the same measure. Okay, so we use this little equal sign with a little squiggly above it to read congruent to. And that's kind of our indication here that these are the same length. Okay, so lengths are equal, segments are congruent. So actual measurements are equal, and then when we talk about figures, we talk about them being congruent. Okay, so it can get a little bit confusing, but for the most part, you'll kind of get the hang of it after we practice it. So it's correct to say that AB equals CD, and that segment AB is congruent to segment CD, more of the picture versus the value. But it wouldn't be correct to say that our segments are equal. So we don't put segments equal, we put segments congruent. The actual figure itself, we put them congruent. So this would be a value, and we want to make sure that it's equal, not congruent. So lengths or values are equal, segments, pictures, congruent. Okay. All right, so taking a look at this, the word time. So if we kind of looked at T here, I'm going to hopefully draw it. It's not the prettiest, but you get the idea. So basically, what segments we have would be the same, would be this one would be the same as this one, which would be the same as this one, and this one, and this one. And then these would be congruent, and these would be congruent, and these three would be congruent. Okay, so if we were looking at them kind of the horizontally and then the vertically kind of lining up, those segments are congruent. And we use tick marks to kind of mark that. All right, so go ahead and fill out these thinking questions and process what you have learned in this lesson 1.2.